part that I tried to skip. And oh, you need the TV to be on? Wow, so needy.
We're high
We are
maintenance.
Yeah, you guys are super high maintenance. Um, is something that I call the lone candidate test. Now, whereas apparently lots of textbooks have the candidates test in it, almost none of them have the lone candidate test in it. So this is a special case that lets you go from a local argument to a global argument. It is the only time you can go from a local argument to a global argument. And what it says is that if f is continuous on an interval from a to b, open or closed, right? Now, the candidate test, it had to be a closed interval. And x equals c is the only critical point. There can't be any other critical points on the interval. Then f has an absolute maximum of f of c if f has a local maximum at x equals c. And if f has an absolute minimum of f of c if f has a local minimum at x equals c. So basically what they're saying there is if you have an interval, it doesn't matter whether it's open or closed, and let's say the graph looks like that, well, there's only one critical point, right? And that's clearly a local maximum, so it is the global maximum, the absolute maximum of this function on this interval, open or closed. Okay? It comes in handy from time to time. So let's look at these two examples. For each function, find the maximum and minimum value if they exist on the domain given. Justify your answers. Okay, so this is an open interval. So my extreme values can't happen at the endpoints because there are no endpoints. There are end holes, right? So let's take the derivative of this thing. F prime of x is going to be 3x times cosine of x minus 3 sine of x. It's sine of x times 3. I just went ahead and moved the 3 in front. All over 3x quantity squared. Is there any place where this doesn't exist? X is 0. Is that a worry for us? No, because it's not in the interval. So I don't have to worry about that. So I set this equal to 0, and I just need to set the numerator equal to 0. So 3x cosine x minus 3 sine x equals 0. And if you want to divide both sides by 3 so that you don't have to type that in, you could do just x cosine x minus sine x equals 0 on the interval from 0 to 5. So we grabbed our calculator. Wow, that went to sleep in a hurry. So clear that out. X cosine x minus sine of x is 0. We'll graph that. Oh, I should have changed my window from 0 to 5. And there's only one place where it could happen. Since that's the only critical point, and we're looking at the derivative now, the derivative went from negative to positive, so the function went from decreasing to increasing, so there's a local minimum of f at this point, and you can substitute it back into the original to find what that is. Okay? Sorry about that with the last page.